Hello, we are going to start with the next section, that is 7.2. Please give me a minute. I'm going to share my screen. 7.2 deals with trigonometric identities, trigonometric integrals, that is antiderivatives that uses trigonometric identities. So first, some useful trigonometric identities. First one is sine square theta is equal to 1 minus cos square theta. Second is cos square theta minus sine square theta. Cos square theta is equal to 1 minus sine square theta. Third one is secant square theta is equal to 1 plus tan square theta. Fourth is tan square theta is secant square theta minus 1. Fifth, these four are known by the name Pythagorean identities. The fifth one is cos square theta is equal to 1 plus cos 2 theta all divided by 2. Sine square theta is equal to 1 minus cos 2 theta all divided by 2. Those two are the power reducing formulas. Now let us start with question number 2 from the textbook. Number 2 is evaluate integral sine cubed theta cos to the 4 theta d theta. This is a product of sine and cosine, and in that case what you have to observe is exponent of cosine is even and the exponent of sine is odd. In that case, your substitution must be u is equal to cos theta, and so u is equal to cos theta, du is equal to negative sine theta d theta, and because du over d theta is negative sine theta, so sine theta d theta is equal to negative du by multiplying this by a negative 1. And now rewrite sine cubed theta as sine square theta times sine theta, and the sine square theta is 1 minus cos square theta. So the integral becomes 1 minus cos square theta times cos to the 4 theta times sine theta d theta. 1 cos theta is u, so this is 1 minus u square times u to the 4 times negative du. You distribute, you have negative u square times negative u to the 4 is u to the 6 minus u to the 4 du, and that is equal to u to the 7 over 7 minus u to the 5 over 5, that's the power rule, plus constant of integration. Now you replace cos theta. Cos theta is u is the same as cos theta. So the answer is cos theta to the power of 7 means cos to the 7 theta over 7 minus cos to the 5 theta over 5 plus constant of integration. Question number 4. This is a definite integral, and this definite integral is sine to the 5 theta, sine to the 5x dx. So rewrite that as sine to the 4x times sine x dx. Integral x varies from 0 to pi over 2. Sine to the 4 is sine square x the whole square. And so rewrite sine to the 4x as sine square x the whole square times sine x dx. Sine square is 1 minus cos square x. So it is 1 minus cos square x the whole square dx. Again, the substitution is u is equal to cos x. So du is negative sine x dx. And so sine x dx is negative du. So here the integral becomes integral x varies from 0 to pi over 2, 1 minus u square times the whole square minus negative du, 1 minus u square the whole square. First I pulled out that negative sign, and then 1 minus u square the whole square is 1 minus 2u square plus u to the 4. If you do not remember the formula, you FOIL 1 minus u square with 1 minus u square, and then combine like terms, you get 1 minus 2u square plus u to the 4 d. And now integrate, that is negative sign is outside, u, antiderivative of 1 is u, antiderivative of u square is u cubed over 3, plus u to the 5 over 5. Now replace u is cos x. So negative cos x minus 2 times cos cubed x over 3 plus cos to the 5 over 5x over 5. X varies from 0 to pi over 2. So substitute the limit. Cosine pi over 2 is 0. So when you substitute first, you have negative 0 minus negative cos 0 is 1. So this is 1 minus 2/3 plus 1/5. Simplify, you get 8 over 15. And so the answer is 8 over 15. There is a shortcut to evaluate this integral, but this shortcut works only when the limits are from 0 to pi over 2, and it is either the power of sine or the power of cosine. So this is how it works. Here is a shortcut. See, what you have to do is 5, your exponent is 5, 4 times 3, 2, and if it is an odd number, then you multiply it by a 1, and so this is times multiply this by a 1. If it is an even number, the exponent is even, you have to multiply by pi over 2. So the answer in this case is 4 2s are 8 divided by 5 3s are 15. So that is the answer. So you may use this formula to verify your answer. This works only when the limits are 0 to pi over 2, and it must be either sine to the power of n or any number, or cosine to the power of any number. If it is even, then you have to multiply by a pi over 2. If it is odd, you just multiply by a 1. So this is the shortcut to evaluate it. Okay. Okay, next is t times cos to the power of 5 t square dt, and you need a substitution here. Let t square is equal to x. So 2t dt is equal to dx. That means t dt is equal to dx over 2. So it becomes cos to the power of 5 x, t square is x, then t dt is dx over 2. And now pull out that 1/2, and then just like the previous case, you split it. Cos to the 5x is cos to the 4x times cos x dx. Cos to the 4x is cos square x the whole square times cos x. That is 1/2 times cos square x is 1 minus sine square x. So it is 1 minus sine square x the whole square times cos x dx. Here the substitution is u is equal to sine x. So du is equal to cos x dx. And so the integral becomes 1/2 integral 1 minus u square the whole square du. That is equal to 1/2 integral 1 minus 2u square plus u to the 4 du, and that is equal to, you find the antiderivative. Antiderivative of 1 is u, so u minus 2 times u cubed over 3 plus u to the 5 over 5 plus the constant of integration, and now u is the same as sine x. So 1/2 sine x minus 2 sine cubed x over 3 plus sine to the 5x over 5. Now what is x? X is t square. So 1/2 times sine t square minus 2 over 3 sine cubed t square plus 1 over 5 sine to the 5x plus constant of integration. Next. integral 0 to 2 pi sine square 1/3 theta d theta. First, let us use a small substitution. Let 1/3 theta is equal to u. So theta is equal to 3u. D theta is equal to 3 du. So this becomes theta varies from 0 to 2 pi sine square u times 3 du. Now you use the power reducing formula here. So sine square theta is 1 minus cos 2 theta over 2. So this 3 is pulled out. Then integral u theta varies from 0 to 2 pi 1 minus cos 2 u divided by 2 du, and it pull out that 2, so it becomes 3 over 2 outside. And the derivative of 1 with respect to u is u. Then you have a cos 2u here, and the derivative of cos 2u is sine 2u divided by 2. Theta varies from 0 to 2 pi, but u is 1/3 theta, so that is 3 over 2 times theta over 3, 1/3 theta minus sine minus 1/2 sine 2 theta over 3. Now substitute the limit 3 over 2 times 1/3 times 2 pi upper limit minus 1 over 2 times sine 2 times 2 pi over 3 minus, when you substitute the lower limit, that is a 0. So simplify, that is 3 over 2 times 2 pi over 3 minus 1/2 times sine of 4 pi over 3. Sine 4 pi over 3 is negative square root of 3 over 2. You may use the unit circle. So the final answer is, you distribute this, you get 2 pi, 2 over 3 cancels here, and then plus 2 negatives makes a positive, 3 square root of 3 over 2 times 2 times 2, 8. So final answer is pi plus 3 square root of 3 all divided by, pi plus 3 square root of 3 over 8. Question number 12. Integral 0 to pi over 2 minus sine theta, the whole square. Yes, you FOIL that 2 minus sine theta times 2 minus sine theta, and then combine like terms, you get 4 minus 4 sine theta plus sine square theta d theta, and use the power reducing formula for sine square theta. So this is 4 minus 4 sine theta plus 1 minus cos 2 theta over 2. This is 4 minus 4 sine theta plus 1/2. You are distributing the 2. 1/2 minus 1/2 cos 2 theta d theta. 4 plus 1/2 is 4.5, which is 9 over 2, minus 4 sine theta minus 1/2 sine 2 theta d theta. Now it is time to integrate 9 over 2 times theta plus this becomes plus, because negative 4 times antiderivative of sine is negative cosine. So it becomes a positive. Negative 4 times negative cos theta minus 1/2 times sine 2 theta divided by 2. Theta varies from 0 to pi over 2, and substitute the limit. 9 over 2 times pi over 2 minus 0, lower limit is 0, plus 4 times cos pi over 2 minus cos 0 minus 1/4 times sine pi minus sine 0. Sine pi is 0, sine 0 is 0, so the whole thing goes. Simplify, you get 9 over 2 times, that is 9 pi over 4 plus 4 times cos pi over 2 is 0. 4 times 0 minus 1, cos 0 is 1. So final answer is 9 pi over 4 minus 4. Number 14. sine square 1 over t whole divided by t square dt. First, you have to use a substitution. Substitution is 1 over t is equal to u. Therefore, du over dt is negative 1 over t square. Therefore, du is equal to negative 1 over t square dt. Therefore, 1 over t square dt is negative du. So, this becomes sine square u times 1 over t square dt is negative du. So, it is integral sine square u times negative du. Apply the power reducing formula. Pull out the negative sign. Sine square u is 1 minus cos 2u over 2. Pull out the 2. It becomes negative 1 over 2 outside. Antiderivative of 1 is u. Antiderivative of cos 2u is sine 2u divided by 2 plus c. Now you replace your u. This is negative 1 half times u is 1 over t minus 1 half times sine 2 over t. U is 1 over t. So 2u is 2 over t plus c. And you may stop there. That is the answer. Okay. Here, number 16 is antiderivative of tan square x times cos cubed x dx. We know tan x is sin x over cos x. Therefore, tan square x is sin square x over cos square x. And cos square x cancels with the cos cubed x, leaving a cos x in the numerator. So it becomes sin square x times cos x dx. Substitute u is equal to sin x. Therefore, du is equal to cos x dx. And so the equation, the antiderivative becomes integral u square du, which is u cubed over 3 plus constant of integration, u is sin x. So sin cubed x over 3 plus constant of integration. Number 18. Integral sin x times cos x over 2 dx. You substitute 1 half x is equal to u. 1 half x is equal to u means x is equal to 2u. Therefore, dx is equal to 2 du. And so sine x, that means sine 2u, cos u, then 2u, 2 du. Now you again another trig identity, sine 2 theta is 2 sine theta cos theta. So this is, you have a 2 sine 2, this 2 is pulled out. Yeah, I think there is a mistake here. Number 18, there is a mistake there. That is sine 2u is 2 sine u cos u. So there is one more u here, one more 2 there. And so this final answer is not right. I will redo number 18 later. Okay, number 22. Question number 22. Tan square theta and the derivative of tan square theta secant to the 4 theta d theta, that is tan square theta times secant square theta times secant square theta d theta, that is tan square theta times secant square theta is 1 plus tan square theta, then secant square theta d theta. Your substitution is u is equal to tan theta, so du is equal to secant square theta d theta. So this is u square times 1 plus u square secant square theta d theta, that is u square times 1 plus u square du, that is u square plus u to the 4 du, and that is u cubed over 3 plus u to the 5 over 5 plus c, that is tan cubed theta divided by 3 plus tan to the 5 theta divided by 5 plus constant of the integration. That's it. Next is number 24. Integral tan square x plus tan to the 4x dx. First you pull out a tan square x. So it becomes tan square x times 1 plus tan square x dx. 1 plus tan square x is secant square x. So this is tan square x times secant square x dx. So let u is equal to tan x. So du is secant square x dx. So it becomes u square du, which is u cubed over 3 plus c, that is tan cubed x over 3 plus c. Now, next one is integral secant to the 6 theta tan to the 6 theta d theta. You write secant to the 6 theta as secant to the 4 theta times secant square theta, because we know secant square theta is the derivative of tan theta. So rewrite it as secant to the 4 theta times secant square theta times tan to the power of 6 theta. Secant to the 4 theta is secant square theta, the whole square, times tan to the 6 theta times secant square theta d theta. And now replace secant square theta is 1 plus tan square theta. So it becomes 1 plus tan square theta times tan to the 6 theta times secant square theta d theta. U is equal to tan theta. So du is equal to secant square theta d theta. And therefore it becomes theta varies from 0 to pi over 4, 1 plus u square the whole square times u to the 6 du, and FOIL the 1 plus u square the whole square. (26) continues. So 1 plus u square the whole square is I replaced the limit for u. U is equal to tan theta. So when theta is equal to 0, u is equal to tan 0, which is 0. When theta is equal to pi over 4, u is equal to tan pi over 4, that is 1. So the limits of u are from 0 to 1. 1 plus 2u square plus u to the 4 times u to the 6 d theta. 1 plus u square the whole square is 1 plus 2u square plus u to the 4 times u to the 6. So that is distribute u to the 6 plus 2u to the 8 plus u to the 10 du. Apply the power rule. U to the 7 over 7 plus 2 times u to the 9 over 9 plus u to the 11 over 11. Substitute limit for u. U varies from 0 to 1. This is 1 over 7 plus 2 over 9 plus 1 over 11. You may use the calculator. The answer is 316 over 693. There it is. 1 over 7 plus 2 over 9 plus 1 over 11 is equal to math. Fraction is highlighted. 316 over 693. Next, question number 28. Tan to the 5x times secant cube x dx. So this is tan to the 5 is tan to the 4 x times tan x. Secant cubed is secant square x times secant x. So this is a technique when both the exponents are odd. Secant to the 4x, tan to the 4x times tan x, secant square x times secant x. That is tan to the 4x is tan square x the whole square. Then you have secant square x, then secant x times tan x dx. Tan square x is secant square x minus 1. So it is secant square x minus 1 the whole square times secant square x times secant x times tan x dx. Now use the substitution. U is equal to secant x. So du is equal to secant x tan x dx. So secant x tan x dx is du. This is u square minus 1 the whole square times u square du. That distributes u square u to the 4 minus, no, it's not time to distribute u, FOIL this. U square minus 1 the whole square is u to the 4 minus 2u square plus 1 multiplied by u square du. Now distribute u square. You get u to the 6 minus 2u to the 4 plus u square du. Now use the power rule. That is equal to u to the 7 over 7 minus 2 times u to the 5 over 5 plus u to the 3 over 3 plus c. And u is the same as secant x. So it is secant to the power of 7x over 7 minus 2 times secant to the power of 5 over 5 plus secant cubed x over 3 plus constant of integration. Number 30. This is a definite integral. Okay, so tan to the 4 t dt. You write it as tan square t times tan square t and replace one of the tan square t. So this becomes secant square t minus 1 times tan square t dt. Tan square t times secant square t dt minus integral tan square t dt. This is u square du, where u is equal to tan t. U is tan t, so this is u square du. And here you write it as secant square t minus 1. This tan square t is replaced by secant square t minus 1, whereas you substituted tan t is equal to u in this case. So this is integral t varies from 0 to pi over 2 u square du minus integral 0 to pi over 4 secant square t minus 1 dt, and this is u cubed over 3 minus, and a derivative of secant square t is tan t, so this is minus tan t. Then you have two negatives, that makes a plus, so plus, and a derivative of 1, that is t. And now u is tan cubed t over u is tan t, so u cubed over t is tan cubed t over 3 minus tan d plus t. Substitute from 0 to pi over 2. Upper limit tan pi over 4 is 1. So it is 1 over 3 minus 1 plus 1. The lower limit is completely 0. So this is 1 over 3 minus 1 plus pi over 4. Answer is pi over 4 minus 2/3. Number 32. This is tan square x times secant x dx. Rewrite tan square x as secant square x minus 1. You get secant square x, distribute secant square x times secant x minus secant x dx. That is secant x times secant square x minus integral secant x dx. This is, you call it I1 minus I2. I1 is, you are doing the integration by part here. First function is secant x. Its derivative is secant x times tan x. So g prime is secant square x. So that is secant square x. Its antiderivative is tan x. So that is going to be secant x times tan x minus integral secant x times tan square x. That is I1. We are talking about I1. And that is equal to secant x times tan x minus integral secant x times tan square x is secant square x minus 1. That is equal to secant x times tan x minus secant cubed x plus two negatives makes a plus. Dx is missing here. So minus secant cubed x dx plus secant x dx. So that is equal to secant x times tan x minus I. This is nothing but I plus antiderivative of secant x is natural log of secant x plus tan x. And so move that I1 to the left side. This is not I, this is I1. So this is I1. Move that I1 to the left side. You get 2 I1 is equal to secant x times tan x plus natural log of secant x plus tan x. Therefore, I1 is equal to secant x times tan x over 2 plus 1/2 times natural log of secant x plus tan x. So this is value of I1. And now I2 is direct formula because I2 is natural log of antiderivative of secant x, that is natural log of secant x plus tan x. So integral tan square x times secant x dx is I1 minus I2, and that is secant x times tan x over 2 plus 1/2 natural log of secant x plus tan x minus natural log of secant x plus tan x. 1/2 minus 1 is negative 1/2. Final answer is secant x times tan x divided by 2 minus 1/2 times natural log of secant x plus tan x. I know this is not very easy one, so you please practice it. Yeah, that's all. And remember, there was a small mistake on number 18. And that mistake is, I'm going to fix it now. See here, there is a 2 here. So this 2 is a 4, and this is a 4. This is a 4. And so this is negative 4 over 3 times cos cubed u over c. So for number 18, I'm going to write the answer here. For number 18, sine 2u is 2 sine u cos u. So the 2 is missing here. That 2 together with this becomes 4. So it is going to be 4 times t square times negative dt. So the final answer is negative 4 t cubed over 3. That is negative 4 over 3 cos cubed u over cos cubed u plus c. U is 1/2 x. So this is negative 4 over 3 cos cubed 1/2 x dx. So please fix that mistake. This is a negative 4 over 3. Yes, so that is the end of 7.2. I highly recommend you to practice all these problems, and I will post the homework assignment problems later.